Hello, I'm Brian Nordland, the IBMI PowerHA Development Architect, as well as the lead developer for the external storage technologies within the PowerHA product. Today we're going to do a quick demo of a PowerHA switchover or role swap, and we can see just how easy and integrated the entire process is. Before we get into the heart of the demo though, I want to give a quick overview and review of what our environment looks like, as well as some of the core PowerHA concepts. Within our environment, we have two IBMI systems. One of them is called Node 1, and the other one, Node 2. PowerHA is built upon the IBMI clustering infrastructure that is very tightly integrated into the operating system. This provides the communication between these cluster nodes to facilitate handling of any events that occur, such as a system coming up or going down, as well as provide a single point of management and control. In the environment we have today, our systems happen to be some distance apart, so they each have their own external storage system that has its own respective operating system disk units within the storage subsystem. Today I'm using the IBM SAN volume controller for our storage subsystem, but be aware that PowerHA has technologies that work with the entire IBM Storewise line, as well as the DS8000 line, and internal storage as well. PowerHA uses a technology called hardware replication. This provides an inherent simplicity and ease of management by replicating your data at the bit and byte level. Now, in order to do this, we need to isolate your applications and data from the operating system and then replicate it. In the PC world, this is similar to moving your documents to a USB drive that you can then move around to different systems. Now in the IBMI world, this isolation onto a separate set of disk units that we can move to different IBMIs is called an Independent Auxiliary Storage Pool, or IASP. And once set up, it's very integrated into the operating system, so much so that users' day-to-day operations seldom have to change from their procedures prior to an independent ASP. In our demo today, we're going to be using Global Mirror, but the switchover process is the same regardless of the underlying technology. In order to manage switching of our IASP, the cluster provides something called a Cluster Resource Group, or CRG. This tells us who is currently the primary node and owns the resources, and what system or systems are the backup systems and what order. And this really provides the mechanism for controlling switching. Now, in addition to the IASP resource in our cluster resource group, we can also define other resources to switch, such as an IP address. Let's jump over to the demo now. I have an application here that is running on the IBMI. It's a web application, a simple hotel management system. We have a dashboard here with some data. We can see what reservations there are, sort on them, create new reservations. And I've also added to the top right here an indicator of what system we're on and what the status of that system is. Right now, we can see that we're on Node 1. So with that, let's do a switchover. To do a switchover, I can start from the IBMI and do work clue, or work with cluster. Now, since everything is running in an independent ASP, and that's in a cluster resource group, let's take option 9, work with cluster resource groups. Here we can see I have a single cluster resource group called myCRG, and the primary node is node 1, just like the application shows in the upper right corner. So to do our switch, let's take an option 3, change primary, and hit enter. What this is going to do is it's going to go out to the external storage. It's going to double check, does everything look okay? Is that global mirror active, caught up, and so forth? And once it's done that, then we're going to come back to the system and we're going to actually start to initiate the switchover process. And part of that involves ending any applications that are accessing the independent ASP, and then flushing everything out of memory as well. And we do provide a way that you can see this process of kind of taking the independent ASP down with a command called display ASP status. And so if I look at this command, we can see how far along we are. We've actually finished the vary off of this independent ASP. So it's then going to go do the switch on the external storage. And then once that switch on the external storage is complete, it's going to do a vary on of the independent ASP on the other side. And that's kind of like a subset of the IPL process. From the user's perspective here, I have this rich web application. So let's go and create a reservation here. And maybe I'll create it for myself. And I want to check in on the 23rd, and I'll check out on the 1st. So if we create a reservation here, from my perspective as the user, this might take a while because that system is actually down and in the switch. If we go back to look at the status of it, we can see how far along are we on coming back up. And you can see that the independent ASP is kind of going through that subset of the IPL process. And on this system, it takes probably about a minute or so to go through this. But then we should see that our reservation is created. So now it should be up and starting up our web server and everything. So if we look back at our screen here, we should see, okay, our reservation was created. We're now running on node 2, and there's my reservation. The switch was really that simple.